Practice Incorporated. And the hilarity we have is that anytime we go to Meetup and say, hi, Ron, I'm with Private Practice, you think that I'm just a freelance worker. But our business is about, we have tools for maternity care, software tools mostly. And we are focused on maternity care research, we're focused on electronic health records and patient education, sort of the whole realm. That's our space. My co-founder and our CEO is a midwife, and it's just kind of fun because she's CEO and midwife. It's like two completely different cultures and ways of thinking, but that's what makes us interesting and fun. So wanted to build some awareness, so I wanted to sponsor the event tonight. So when Kevin was saying, hey, I want to talk functional JavaScript, we're really interested in these topics, so I wanted to go and sponsor. They're cold drinks. I just picked those up, and if I'm left with like the bulk of those, I'll be really sad. So if you want a Pepsi, that's a throwback Pepsi made of sugar. There's also Mountain Dew, and then there's Diet Pepsi. So feel free to grab one, or I will personally get you one after this speech if you want one. So anyway, the main thing was I run meetups myself, and I know that if you want to engage developers and tell them you exist and the cool things you do, you should buy them pizza and have a meetup and give them free soda or free beer depending on the meetup. And so that's basically what I want to do. I just want you guys just to know that we're around, that we exist, that we're hiring, that if you or your friends are interested in working in this kind of organization. There are 3 of us here who are the core engineering team. It's myself, Dan.
Hello.
And Kai.
Hello.
And so this is our office. We moved here in May. The company was started 3 years prior and basically built in my basement. Hi.
What's your technology stack?
We use a lot of Python and JavaScript. And so we're increasingly moving more and more out of HTML templates that are rendered on the server side and into AngularJS on the client. And interestingly enough, Kai has been following Angular from like its very inception. So Kai is the reason we're using Angular, and we like it a lot. So yeah, that's us. We're hiring. I have a job posting that we recently filled from a guy from Milwaukee, very talented. And so I managed to get someone to relocate, but I know people are here in town too. So I've got a job posting, and just in general, like if people are, just to know that I want you to know that we're here and what we do. And the other thing I would be totally missing out if I didn't tell you this, and most of you maybe already know, but this Friday and Saturday is a conference that is free and awesome. It's called VCamp. It's at City Space on the downtown mall. So if you come on Friday night, this Friday, at like 5 or 6 p.m., so the doors open at 5, it's rolling around 6, there'll be beer and pizza, but it's Christian's pizza this time, and a lot of it. And the idea is to be social, and everyone will bring what they're interested in and pitch some topics that they want to get on the Saturday conference. So basically, Saturday when you come, it's like a developer conference that you go to, that you pay hard money for, that you travel to. The difference is that it's free, and it's here in Charlottesville. And you show up on Saturday, and there's like a whole conference agenda laid out. The difference between that and a normal conference is that conference agenda was created entirely the night before by the people who were eating pizza, drinking beer, and mingling about different things. So it's called VCamp, and you should go. So it's my other pitch. I happen to be the organizer, but I have nothing to do with it. So okay, so to introduce our speaker then, so Kevin Vulture is a developer at Willow-Tree Apps, another fine company in town, and you're part of the web application team, or the WAT team.
The WAT team.
So Kevin has been really interested in how to apply the different functional programming techniques, particularly those you'd find in a language like Haskell, to JavaScript, and using various tools to make JavaScript even more functional. So is that a suitable introduction?
Perfect.
Okay, great. So without further ado, Kevin Vulture, everyone.
Thank you. So let me preface this. Like I said earlier, I went into this talk wanting to be a discussion, and then it turned into a talk. So anytime, this is an extremely, well, it might be terse. So if I start losing people, stop me, because it just gets exponentially more crazy. Because that's functional programming. Second, who already has a background in functional programming or Haskell? Ish. Cool. So also underscore. Anyone who's used underscore before? Underscore. Okay. So gauging that. So yes, I wanted to talk about functional JavaScript. This is all sort of Haskell inspired. I wanted to give a shout out to Private Practice. Thank you for hosting.
Yeah, thanks. Thanks. Nice logo.
Alright, yeah.
You even got the heart.
You got the heart. And then also shout out to B Camp or whatever camp. The bees.
Awesome.
So maybe we could talk about that after. So this is sort of the outline of the talk. From a really far away perspective, we're going to talk about underscore, some of the cool methods in there, how you can use them, really high level underscore stuff, and then some functional concepts that we can use in OO JavaScript. One of the things that interested me is JavaScript is it has its foot in both worlds. It can be purely functional, it can be purely inheritance based with prototypes, it can be whatever you want it to be. So you can take these functional concepts and apply it to your code as is, and you'll still benefit. You don't need to jump ship. So these functional concepts, we'll sort of go over them, and then if there's time, we can go over a demo of what some pure functional code looks like. So to start off, underscore and Lodash, they're just polyfills. So not all browsers have for each, map, reduce, these sort of functional methods that we're used to, or we will be used to soon. So you go back in IE, even Chrome and Firefox, they don't have all these methods. So what underscore and Lodash do is they standardize them, sort of like jQuery for the DOM. These libraries sort of standardize functional methods for us. And they also provide some other really nice methods. We'll go over them. But sort of what I feel the highlights for underscore are these sort of 5 methods. Reduce, map, pluck, filter, and find. These are sort of like my go-to methods that I use every day, all day long. So we'll go through them real quick and then maybe touch on a few others. A reduce, or also called fold, is the granddaddy of all sort of iterators. So in functional languages, you can pretty much make any iterator with reduce. It's a fun practice to do. You start with reduce. First you make reduce, and then you make map, and then you make pluck, and then you make filter. It's interesting to do. And what reduce does is just takes a list and reduces it down to a single element. It could be another list, it could be a single value, it could be a Boolean value. It just reduces it down. Also, if I'm talking either too fast or everyone already knows this, point this out to me, because this is new. Talking is new for me. Normally I don't do it. Okay. Next, map. Map is the go-to iterator. And it's even, so coming sort of from a classical imperative style, I used to always use each, for each element in a list. And then sort of once you're used to a functional paradigm, you use map. Map is your default iterator. And the reason we do this is map enforces pure code. Whereas each, the only reason you want to use each is to cause side effects. And typically side effects are bad in functional programming. So it's your go-to iterator. And what you do is you iterate over a list and you modify each object in that list, and then you return a new list, a new copy of that list. Pluck is the most common use case for map. So what you're doing is you're iterating over a list of objects, and you're returning one property from each of those objects. So you have a list of people, right? And people have arms, eyes, ears, whatever, names. If you pluck the name from those guys, you get a list of just the names of all those people.
Can you pluck multiple, or is that not? Is it typically one?
Typically one. Well, I might be lying to you. I need to read the documentation.
But in practice?
In practice, you just do one.
Okay.
And if you want to do more, you just use map, and then you can just grab all the ones you want. Well, I can show that later.
Okay.
So filter. So before these previous two, so these previous 3 are mutators. They'll mutate a list. So you provide a transformer to your iterator, and that transformer gets called on each object. These next few, like filter and find, they take predicates. And a predicate is just a function that returns true or false, right? So with filter, we give this function a predicate, and the first item that returns true, we return that item. So you're just finding the first item that returns true in this list. Just kidding, that was filter. So filter only accepts the items that return true, and find accepts the first element that returns true. So those are sort of the 5 power horses of underscore, and there's so much more to it. Underscore has a bunch of predicates, is array, is null. It has so many nice methods. Chain and compose. One of the things that, who's familiar with chain in here? Chain. After this you'll see why compose is so good. I used to use chain all the time. Extend is awesome. So we can talk about these methods later if anyone's interested and they aren't familiar. So we'll jump into some other stuff. So sort of the high-level differences between functional programming and object-oriented programming. I guess JavaScript isn't object-oriented, right? It's prototype-based. So whatever, functional programming versus everything else. With functional programming, the language of the language is different. So you can think of OO as a language of nouns, right? So if you want to do something new, you make a new noun. So if you have a base car and you want a new car, you make a Ferrari. And the Ferrari has all of its data hidden in it. If you want to do something new in functional programming, you use verbs, where verbs are functions, right? So if you want a new car, you take your base car object, and then you make it a fast car, and then you make it a fast red car, and then you make it a fast red car with 4 wheels. And you just stack, I guess none of those are action verbs, but you get the point. You stack on functions on top of functions. So the complexity in these two paradigms, with object-oriented, data is it hides your complexity. So you make a new car, and that Ferrari hides the complexity of the Ferrari. With functional programming, you take these simple methods, you build them up, and those composed methods hide the complexity for you. So conversely, data types in functional programming are typically lists, simple objects, strings, numbers, whereas data types in object-oriented are huge data types, right? Or hopefully not too huge, but they're bigger. So those are sort of the things I wanted to point out now. There's tons of differences, but those are the ones I wanted to bring up. So we'll get started with functional concepts. Any questions before we get started? Cool.
I have a quick question.
Yeah.
So map, even if you can use it on an object, but it always returns an array, which is kind of annoying because if you think that you're mapping one object to another object in some way, is there some kind of principle in functional programming that dictates that that's how it should
No.
So
work?
if I understand the question, is there another method besides map that doesn't return the list?
Well, I think, so I was tripped up the first few times. I experienced the map method and an underscore because I think the Ruby version of map doesn't always return it.
It'll iterate through and you can tell if it returned maybe. I'm not sure.
Yeah, I know you can use reduce to do what I'm talking about. But I was just a little bit surprised that you can iterate over each key value pair in an object, and it's always going to return an array.
Yeah. So that's one of the crazy things with underscore. All these methods that we talked about before, all these collection methods, they work on objects and arrays, but if you use them on an object, it returns an array. So it can really F you up if you don't know what you're doing. But it's
intentional?
Pardon? Yeah,
Is
it
that
is.
intentional?
It is intentional.
I didn't phrase it well, but I was
But
just
you-
wondering whether there's some sort of philosophy of functional programming.
Yeah, it feels that's
It is
broken.
I think traditionally they have separate iterators for objects and arrays. Like in some of the other functional libraries, they have separate iterators. I've sort of grown fond of how underscore does it. It just sort of reduces the things you need to think about, but it can really F you up.
I worked on a project one time where we kind of took that philosophy where our repositories would always return collections, even if it was a method that would almost certainly only return one object. We'd still put it in the collection, the idea being you always knew you were running a collection, which made it a lot easier to anticipate things. Not to mention reduce the possibility of like null errors.
Yeah.
You might get empty collections, but no nulls.
Yeah.
These methods.
That's where monads come in, right? Do you cover monads?
I don't. Well, I like allude to them at the very end, but monads are. I don't even understand monads. I use them.
Well,
But
if you understand what you just said, that's like the whole. That's like the primary purpose of monads.
Yeah.
So you can chain together these functions and know at the end that you're not getting a null, that you're not getting a scalar unless you ask for one, and that you're getting a list. I mean, it's just that's how you commonly chain these, so
Yeah.
that you can adapt something that's returning an object and pass it into something that needs a different type. So I would like to think that we can embrace, sort of go all in on these, because like you've been learning Haskell as part of this exercise. I mean, Haskell, just like it's got it figured out. It gives you what you need.
Yeah.
It's not always going to return a list unless you said it was a list of the type, and I think it just gets weird in JavaScript when it's not being a duck typed environment. I think that's what makes it weird. And I'm curious to know if you have experiences where duck typing and functional programming get weird.
I'm not that far along, so I don't even know what you're talking about half the time. Okay, sorry about that. But so where did we leave off? We left off at functional concepts, purity. So this is sort of the biggest thing I wanted to cover, purity, because this can be applied to any language or any paradigm. So functional purity, for a function to be pure, you satisfy these paraphrased 4 points. I think there's 2 points, but I broke them up into 4 points. First, the function must be deterministic. So for every input, it has to produce the same output, right? So you can think of there's one line into the function and there's one line out of the function. So it maps 1 to 1 or many to 1, but not 1 to many. Secondly, a function does not depend on external state, because if a function depends on external state, it violates the determinism. So if you return 1 if the state is 2, but 3 if the state is 4, then you're not deterministic, right? 3 does not depend on I/O internally. Again, this violates determinism because it could change over time. And lastly, it does not cause side effects. So if your function call internally affects some other portion of the system, then it's not considered pure. And the reason why this is such a big deal is when your building blocks are contained, self-contained, they don't cause any side effects, and they are deterministic, you can build them up logically. But the second you have sort of these unknown factors like state, when you try and build things up, it's like playing with Legos, and each Lego is a bomb, right? You're gonna get fried because some state's gonna mess you up, and your composition's gonna go terrible. So here's an example of an impure methodology. So we have a backbone view, and we have an initialize method. The initialize method does some stuff, and it calls this.generateList. And this.generateList just sets this.list to a new backbone collection. Really simple stuff. In this case, both of these methods are impure. Well, yes, I think. Maybe, yeah, they are. So initialize is because it has to cause side effects. It relies on state. And generate list is impure because we are pulling in external state, right? So why does this matter? When we're testing this function, to test generate list, we have to mock the view, we have to mock the state, we have to do all these things. Imagine if this function was longer. Testing this can be hard. Furthermore, as these functions grow and we have more state, we have all these entry points into our functions. And so when we're reasoning about this method, we're thinking to ourselves, well, I have to know about the state, I have to know about the input, I have to know about input-output. If this function is pure, you only need to know about one thing, and that's the input of the function. And that's a lot easier to reason about. So we rewrote this in a sort of divided fashion. Now, initialize still is impure. It says this.list equals this.generateList, but now generateList is a pure function. Instead of modifying the list itself, it returns a new backbone collection. So why would we do this? It seems sort of convoluted. But think about it. Generate list is completely independent, right? It doesn't need to be a method. It can be a function, right? To test this, all we care about is the input and output. We don't care about state. It's easier to test. It's portable. It has all these nice properties that I'm not even covering yet. So simple changes like this, just being aware of what functions are pure and what functions are impure, can help reduce the complexity of your code. Next point, thinking of functions as data. So in JavaScript, functions are first-class citizens. So anywhere a number could go, essentially, a function can go. So a function can be a property on an object. A function can be a return value. A function can be a parameter. A function can be a variable. It can be all these things that first-class citizens can be. And that's really cool. Second, once you have these pure functions, you can almost view functions as their return types, right? You no longer view functions as, well, this function is going to modify state and do some I/O and do all this crazy stuff. No, you think this function is going to return an integer, and that's all it's going to do. So we can start viewing our functions differently. They're no longer beasts, they're building blocks. And lastly, just like normal first-class citizen integers, booleans can be modified, functions can be modified, right? So functions can build functions. Functions can do all sorts of crazy stuff. And that brings us to our next point.
Can you elaborate, sorry, on that last point? Why is that different than non-functional?
Why is modifiable function?
Yeah.
Because, so when I'm saying modifiable, it's functions building new functions. So with sort of imperative style of coding, your functions, they can still build other functions, but they're not necessarily pure. And so you can get into these weird states where I'm doing a terrible job
So you can
explaining.
logically
Yeah, logically it's different.
modify, or you can, with confidence, modify
Yes.
functions. or
I'll-
build additional.
Yeah. I'll go, I have like the rest of this presentation is all about building functions
Okay.
and modifying functions.
So would an example be like wrapping a function and knowing that that original
Yes, wrapping a function would be,
function is something that you can use as a building block?
Yes. Wrapping is an example, composing is an example, currying is an example. It's all modifying functions. So jumping into how we modify functions or using functions as building blocks. Sort of the go-to way to build functions is function composition. So function composition is when we string together functions in a linear sequence where the return value of the first function goes to the input of the second function, and the return value of the second function goes to the input of the third function, and so on and so forth. So we have this list of functions and they feed each other, sort of like chain, right? When you chain, you're going down the chain. Composition is the same way, but backwards. We'll show. So let's say we have these functions a, b, and c, and we want to compose them. Can you all see this? I know I should have probably put the important bits at the top, but that's backwards to me. So we have a, b, and c. In the bottom left we see we're calling c with x, and that gives us a return value. We pass that return value to b. That b function now gives us a return value, and we pass that value to a. If we do this with compose, we see we have compose down here, we have c, b, and a from right to left, and we have x at the very end. So what compose is actually doing is it's making a new function. And this function calls c, and then it takes the return value, passes it to b, and then passes it to a. So we have this weird sort of double parens here, where we make a function and we call it immediately. And we'll go through an example of how this works. So we have a simple add function, which is just add one. It takes in a number or something, and it adds one to it. So if we wanted to make, via composition, if we wanted to make a new function called add3, we just compose 3 add ones together. And then if we call it add3 with 0, comments are totally not visible, we'll get 3. So sort of visualizing how this works, we call 0, we call it with 0, it gets passed to add 1 returns 1, and this gets passed to the next add 1. This returns 2, it gets passed to the next add 1, and finally we get 3, which is our ultimate value. So this is how function composition sort of flows your data through a list of functions. Here's another sort of simple example. We have our function not, and not just negates whatever we give it, right? So if in JavaScript, if you want to turn anything into a Boolean, I might be wrong, but what you can do is you just double negate it, right? And it'll first flip it to the other sign, and then negating it again will turn it back. So if you double not undefined, it'll be false. If you double not an empty string, it'll be false, I think, or something crazy. And if you double not true, same thing. So here, if we want to boolify something, we can compose 2 nots together, right? So if we double not a empty object, we get true. So you see how we can call it in the 2 different ways. We can call not and then not again, or we can just call the composition. So do I still have everyone? Yes. So one more example. This is a little bit more complex, but it's still the same stuff. So we have 2 functions, just the same as add 1, but this time we're adding strings. So we have add salutation, which just adds g'day. We have add title, which adds Mr. And we have meet and greet down here, which is the composition of these two functions. So we're just first adding title, then we're adding salutation. So you can sort of think of it as like sort of, what languages read right to left? Like Chinese or Hebrew? It's like reading Hebrew, I guess. You read from right to left and then bottom to top. That's typically how you read, at least what I've been writing, which is sort of crazy.
Inside out.
Yeah, inside out.
Inside out's without the composition. So.
Yes.
Is that the way underscores compose function works, or is that the way?
This is actually how it
dash
is.
loads? Okay.
This is how like the math behind it. There's like a whole math backing to function composition. It comes from category theory or something made up. So like I could put proofs on the screen, but I wouldn't understand them, so I just left them off.
You mentioned that dash low swaps the arguments. So
Yeah.
I was wondering whether
Score under.
score under. I'm sorry.
Score under.
Score under, yeah.
Yeah, I'll go into why this happens. It's with composition and curry. Want to go over that?
Am I crazy, or is there a dash low? Like,
There is a low dash.
I know there's a low dash, but
Is
there
there a dash low?
I don't know if
there's
there's
probably.
Okay.
That sounds like score under. Though.
Score under? Is that a thing?
Yeah.
Yes, I'm using it today. You'll
Score
see.
under is based on low dash, I think. now.
Yes. So the problem sort of becomes apparent when we have more complex functions. Right now we've been working with functions that just have one parameter, but when you try and compose anything with more than one parameter, you start running into these crazy things of how does it compose? So like, let's say we're trying to compose two adds together, right? They both have two variables. So the first time we call add and then 1 and 1. The return value of add is a single integer, right? So we pass it to the second add, and we've only supplied it with one integer. It won't get called. So how do we actually and it's totally unreasonable to limit yourself to only having functions with one parameter. That's totally unreasonable. So the way we get around it is with currying, or one of the ways to get around it is with currying. And currying is the process in which we take a function that has multiple arguments, and we transform it into a chain of functions that accept a single argument. Don't even worry about the definition. Well, as it's sort of confusing, we have this sort of... is there any way to make the screen darker? Or can you all read that
I
comment?
can take these down.
Like,
Is that help?
one's up there.
can you read that better? Okay. So there's this sort of Haskell-inspired notation that we use to document curried functions. And the way we document it is we have this sort of lambda or arrow. And anything to the left of an arrow is a parameter type. Anything to the right of the arrow is a return type. So here we have an arrow with type and type, so we take a type and we return a type. An example is we have a function that takes an integer and returns an integer, right? And then we see we have another function here. We take a type and we return a type. So this 3 chain is a function that takes something of type, returns another function that takes something of type, and ultimately returns something of type. So many types. So examples are how I understood it, so I have a bunch. So how we document not, right? Not takes an A is just any value, any type, and it returns a boolean, right? So we can call not of true and it returns a boolean, right? And any lowercase letter is just, we don't care about the type, it can be anything. But I believe they have to match, so if you have multiple A's, they have to be of the same type. So similarly, we see we have this problem child add. It has A, comma A, and it yields an A. This is a total abuse of notation, right? This is not a curried function, but I'm using curried notation to describe it. We should always have one parameter. So we're going to try and curry add right now. We take add, we run it through our curry thing, and then we have this new function that has add A yields A, which yields a return type of A. So this is what the curried version of add looks like. So we have our outer function, which is called add, and it takes an x. And then when you call this, it returns a function that takes an y, And when you call this second function, you return x and y together. So the way you actually call this beast is down at the bottom. You have to use two parens, right? And this is sort of a visualized way of how the comments line up. We see the first type lining up with the first line. We see the second type that's returned lining up to the second function because there's another arrow. And ultimately we see the blue type, which doesn't have another arrow, yields the actual return of the chain of functions. So let's go through some examples of how to use add in particular and why it's useful. Why would we ever want to use curry? So here, this top line is just the call signature for add. The second line is what we're doing. This third line is the signature for the new function. So we see we're calling add with 1, and we're assigning it to a variable called add1. And what we've done is we've we've applied 1 to add. We see that in the middle line. And then we're left with a function that takes an integer and returns an integer. So now we can call add1 with 2, and we get 3. Any questions so far? There's like 8 more examples, but any questions off the bat? Okay. So similarly, back to the old meet and greet, we can reuse that same add function. Add is now general, right? So we can call add with Mr. or a string. And now we're left, we see in this middle line, we give add a string, and we're accepting now a type of string, and we return a string. So we can call add title with another string, and we get Mr. Baggins. Right? And this is sort of, you see we've built 2 functions from one function, right? We've defined our add function, and now we have 2 separate functions from it. So this is one way functions can build other functions. But there's a problem. This looks crazy. You know, one of the things we try and combat with JavaScript is nested callbacks because it's hard to maintain. And with languages like Haskell, they're automatically curried. They do all of this for you. You don't need to do anything. With JavaScript, we need to do that ourselves. So I'm going to wave my hands and say there's a method called autocurry, and it just curries for us, right? So now we have our original add function, and we call autocurry on it, and it's magically curried. And not only does it clean up our function code, but it also lets us call the function in 2 different ways. We don't need to call it separately, we can call it all at once. So we can call add1 with 2, and we can call add1, and then we can call it again with 2. So now this method has been autocurried. And this is one of the, I don't know if it's a new addition to Lodash, but I was recently reading the Lodash documentation, and its curry method does this for you, which is really nice. So any questions before I jump into a slightly longer example? Nothing? Okay. So more examples. So revisiting sort of the granddaddy of all iterators, reduce. So this is the call signature for reduce, or the way we're going to define it. Reduce takes in a function, it takes in a starting value to a list, and then it ultimately takes in a list, right? So, and then we call autocurry on it because we want it to be curried. So this inner function, this modifier that we're calling, takes in 4 parameters. It takes in the current reduction, it takes in the current value in the list, or the present value in the list, it takes the index of the present value in the list, and then it takes in the list itself. And whatever this function returns gets inserted into the next memo, the next reduction. So using reduce, I guess I should back up a second. Is everyone sort of familiar with reduce? Or I can sort of implement it really quickly if someone wants to see it written out. You want to see it written out?
If you don't mind, that'd be helpful.
Sure. So this is a super simple implementation of reduce. Var reduce equals function, oh my god, how do you spell? Function we'll call autocurry. We don't even need autocurry. So it takes in a function, it takes in the initial value, and it takes in the list itself, right? So we will save our initial value, or we don't need to save it. So what we're going to do is we're going to iterate over the list, right? So var I equals 0, I is less than list.length, I plus plus. I'm doing it imperatively. How crazy is that? So for each item in this list, we are going to call the iterator over it. So init equals function, and then we're going to pass it init, the current value for the reduction. We're going to pass it the current item in the list, so list with index. We're going to pass it index.
You want I.
You are right. I want I. You're going to pass it I, and then you're going to pass it the list itself. And then ultimately you return init, right? So the way you might use this, well, we're actually going to use this in 2 seconds. But this is sort of the implementation, a simple implementation of reduce. So going back to the presentation, where's my cursor? Cursor. Reduce. So the way we would sum all the numbers in a list is, this is a simple implementation. We have our inner function, which takes in the current value, the current reduction, the value that we're iterating over, the index, and the list, right? And we return the current value, the current reduction, plus the value we're iterating over. And then the last two arguments, which are the initial value is 0, and then we pass in items. So once the first value, the first time we're iterating over, our current reduction is 0, right? And our value is 1. So we return 0 plus 1, which is 1. We iterate over the next item, so our value is 2, our current reduction is 1, we return 3, right? So this 3 gets passed to the next value, so current is now 3, our value is 3, so we return 6. And that's what's ultimately returned by this reduction, right? This is where it's just going to get crazy. So with JavaScript, we can omit parameters that we don't use, right? It's a pretty common practice. All the time, when you don't use all these parameters, we can just get rid of them. So we're going to drop index and list because we don't use them in the function body, right? So now we have this new function, or the same function, just a little bit cleaner. We return current plus value. We can simplify it a little bit further because this function looks awfully familiar, right? Current plus value, and then current plus value, right? This is just add, what we defined before. So what we've done is we've renamed the parameters. We haven't even changed the function. But since we've already defined this function, instead of just changing the parameters, we can just pass in the function pointer. So we can get rid of the function entirely because we've previously defined add. Does everyone sort of follow this sort of train of thought? Like, we don't even need to worry about the parameters because JavaScript will call that function somewhere else with the parameters, right? And I can go over this in a different way if it would help. But this is sort of like a big leap of faith right here. Okay. So I'm going to take it one step further because reduce is curried, right? So if we don't supply all the arguments to reduce, that means reduce returns another function, right? Since reduce takes in 3 values, if we only supply it with 2 values, we're left with a function that it's accepting 1 value, right? If we apply reduce with 1 value, we're left with a function that's accepting 2 values. So here, we've made an entirely new function called sum. And the way we've done it is we've called reduce with add and 0. And we're left with a function that is only waiting for data. So we see our item is defined up there. We see reduce, this top line. We've supplied add. We've supplied 0. You see this next thing is an array, so we haven't supplied that yet. So at our current state, sum is a function that is waiting for an array and will ultimately return an integer. So now, just by currying reduce, we can make many methods or functions based off of reduce just by partially applying it or calling it with less parameters than it wants. So here we've made sum, right? So I have a demo lined up unless the demo is essentially going to be all this crazy stuff. But I can talk more about what just happened if that would help. Yes? No? Maybe so.
Do you have a snippet of code you could show us that illustrates a lot of use of these concepts?
Yes. The demo.
Well, except for, I mean like something from a piece of software that you've actually written.
The demo.
Aside from the demo.
Like the demo is actually an excerpt from Autobot, which I made.
Oh, okay.
So
Demo man.
demo it. Okay. So one problem at Willow Tree, we rely heavily on IRC, and one problem we've sort of run into is very occasionally people will say something humorous, and when they do, we want to document it, sort of like bash.org. And it is so tedious to, each time someone says something humorous, to go into the spreadsheet and copy and paste. So I wrote a bot that does that for us. And what this bot does is it just sits in IRC, right? And every time a typical user types something like this, which is often, it looks for votes in this string. And what this is saying is, you have -1 Kevin. So let's say my nickname is Kevin, right? So someone's downvoting me because I said something horrid, right? And then we have Joe getting upvoted here, and we have Test, which obviously isn't a user, but we can deal with that later. So Autobot takes all these messages and parses them for votes, and then ships them off to a database, which we can then have a front end so we can see all the pithy things people say all the time. So I originally wrote this imperatively, and then when I got interested in sort of functional concepts, I rewrote this with score under, and it was tons of fun and really confusing and made me really not like functional programming, but now I really like it again, so I wanted to share.
How long did that take?
It took me this was all within like an hour. It was a really intense period of time. So this playground also, I guess if you have a laptop, you can watch it on your laptop. JSBin is awesome, by the way. I really heart JSBin. But so in this playground, I linked to it. I imported 2 libraries. One's called score under, which is underscore with the arguments reversed, and the other one is called lambda or something.
Gilman, do you need the lifeline?
Lambda,
Oh, no,
it is.
Yeah, it's not
I
that
heard
bad.
it.
Look at it.
You're looking at it. Awesome. So
You guys good?
all on Wi-Fi, awesome. So what Lambda does is it takes all the native methods, ECMAScript 5 and 4. What current one are we on? 5 or 6 or 5? So like it takes for each, it takes map, it takes string.split, and it turns them into functions. So right now they're methods because you have to have, like if you want to call split on a string, you have to have a string, right, blah, and then you can call split on that, right? So what Lambda does is it took this out and curried it. So now we can just say split. We can provide the delimiter, and then we can pass in the string.
Wait, so the library's called Lambda?
Yes, which is,
Terrible name.
I know, right? Because it's, not intuitive, and it's, name collisions, but whatever. So I'm going to do a bunch of stuff that assumes that everything is curried like this. So like an array.push, you provide the data first. So you say push, and then what you want to push, and then where you want to push it. Split, what you want to split on, and then what you want to split, for example. I think those are the only 2 main ones I'm going to use. So things are going to look crazy, but bear with me. Alright, so the way we're going to tackle this problem is we're going to iterate over this input in tuples. So every 2 words, we're going to see if it's a vote, right? So we're going to go over Kevin, -1 Kevin, Kevin +1, +1 Kevin, all the way to the end. For each tuple, we're going to see if it's a valid vote, push it on a list, and then run some data on it. So the starting point to this is getting the data into that tuple format. And the way we're going to do it is by first splitting it based on the words. So we're going to define a function called words, we're going to expect a string, and we're going to output an array. And one thing, when you're writing curried functions, if you don't write these sort of type signatures, you won't understand your own code. It's crazy. So var word, right, equals split, and we're just going to split on spaces, right? So we'll run this, and we see we didn't actually run it. So we actually have to call the thing word.
Word.
Words. Actually, we'll call it words because it probably makes more sense because it's plural, right? Maybe? I don't know. Words. So now we see we've split this input string based on spaces. Pretty basic stuff. So how are we actually going to get this into tuples, right? So we want -1 Kevin, all that stuff. We're going to use reduce because why not? Reduce can do everything you ever wanted to and more. So we'll call it array2tuples. Array2tuples. Tuples. And what this is expecting is it expects an array and it produces an array. And that's what we're expecting. So var array2tuples. And again, we're going to rely on that fact that we're not going to call reduce with 3 parameters. We're only going to call it with 2 parameters. So we're calling reduce with 2 parameters, and what we're left with is a function that accepts an array and returns an array. We're going to start off with an empty list. We're going to pass it a function, right? This function are going to use all the inputs, so it's going to take the memo, the item, the index, and let's make this wider, and the list, right? So anything that gets returned, remember, anything that gets returned from reduce goes to the next value. So we are going to push onto our reduction, right? And the reduction is the memo, and we're going to push a tuple. And all a tuple is just an array with 2 elements. The first element is the current item in the list, and the second element is the next item in the list. So it's list index plus 1, right? So going down here, we can say array2tuples, and then close that guy, and then run that, and then we see that it's terribly cramped. Do you mind if can you still read that in the back?
Mhm.
Yes. So we see we have an array of arrays where each nested array is just a tuple, right? That's pretty cool. Now down here, we can already see that this is totally unreadable. Console.log array2tuples words input. It's hard to follow. There's no white space. There's nothing your eyes can really latch onto. So this is where an abuse of compose really is nice.
Is there a bug in your code?
Is there?
Do you really want tuples overlapping where an element is in the tuple before and the one after?
Yes, because sometimes votes are right associative. So like, let's say this guy right here is not -1. We still want to say that's a vote for Kevin in the first sense.
But the way you've got it right now, if you have the -1 there, you first register -1 Kevin, then you register Kevin +1, then +1 Kevin again. So every number is being counted.
Yep.
People on either side.
We'll get to that.
Okay.
It's all part of the master plan.
Alright, so we just didn't know your master plan.
Yes. So this is where, so what we're doing is we're sort of just building up from the simple things, from low complexity to sort of higher complexities. And the reasons for sort of like, the original way I wrote this was with one gnarly regular expression, and it was terrible. And to this day, Autobot dies every 5 minutes because I haven't fully rewrote him yet. And Adam kills him every other night, unfortunately. So this is the new way I've settled on. So we now have our array of tuples, and you can see this is still bad because we have undefined because we're trying to add the last element beyond index out of bounds, whatever. So we'll deal with that in a little bit. But before we get to it, let's convert a tuple to something more reasonable. We'll convert it to a vote object. Oh, sorry, we wanted to compose. So again, this console.log array2tuples words input is very unreadable. So we'll use compose to clean it up some. So we're going to make a new function, right? And the first thing we want to do is call words, right? We're reading from right to left. And then after we do words, we want to say array2tuples. Then after we do array2tuples, we want to say console.log, right? And that's what we want to do, right? We've made a function, and now we can call it immediately. We don't need to save it. We could if we wanted to. But this is a little bit more readable. We've sort of unnested that hierarchy. No longer are functions getting nested within each other, but we've made sort of a new way to express ourselves. So we run this, and it's the same output, right? So let's iterate over these tuples and change them into votes. So we'll make a new function, and we'll call it tuple to vote. To vote. And what this guy expects is an array, right? A tuple array, which has 2 elements, and we're going to return an object. So
Super quick question on the notation there.
Yep.
Could you write whatever you want? So could you actually put like tuple array just so you know?
Yeah.
Or?
yeah, you could totally do that. You can just say tuple array and then tuple. This is just what I've settled on.
So it's purely for your benefit. Then?
Yeah.
Okay.
So the way I've sort of settled on it is I have this type signature, and then I'll have comments outside of the type signature
Gotcha. Okay.
that sort of describe what inputs are. And I got it from some other guy, and some other guy wrote a little parser, so it just sort of strips out the type signature. It's sort of like UI docs. So var tuple to vote is a function. It takes in a tuple, right? And it returns an object. Return an object. And all a vote is in our system is just points and a username. How do you spell points? That guy. Points and a username, right? That's all a vote is, points and a username. So what we want to do is we want to iterate over each of these tuples, transform them into votes, and then return that list. That's what map does, right? Map iterates over each element in the list, transforms it, and then returns the list. So down here, we're going to use our curry again. Let's go down a little bit farther. Was there a question? Map.
No, I'm just waiting for it to work out.
Waiting for it to work out, okay. So map accepts 2 arguments normally. It accepts the transformer and the list you're transforming on. So what we've done is we've called it with only the transformer. So now map is waiting for the list. So what is happening, we have a string, words expects a string and produces an array. Array to tuples accepts an array and returns an array of arrays. And now map accepts a single array and it turns that single array into an object. So if we run this again, oh gosh, we'll make you a little bit smaller. Awesome. So now we see we have these objects which are points and usernames. So we have one of these for each of the tuples we have. But this isn't useful because they're just empty strings. So how do we actually transform this in a reasonable way? So what data do we have right now? Each individual element is an array, and we want to find out if that array contains a string that represents an integer. So we'll use find, right? We want to search our array for something, and if it exists, perfect. If not, return undefined, right? So we want to find out in our tuple if we have a string that represents an integer. So the way we do that is we define a custom predicate, right? So var is vote string is just a simple predicate. Make the comment. And what it is expecting is a string, right? And it returns a Boolean. And how do we actually test a string? We can just use a regular expression. So we'll use the test method on a regular expression. That is not the one I wanted. It is that guy. And what this regular expression is doing is it just looks for plus or minus and then 1 or more digits, right? So we have our array of strings. We can call find with this is vote string, run this, and we see now points have been populated, right? So up here we have -1 because it found that in the first tuple, and then +1's all the rest of the time. Right? Pretty cool. And we can do the same thing for username. Essentially, a username is anything that is not a vote, or anything that is not a point, right? So we can just copy pasta this. So copy this, and then negate it. Now, you'll notice this doesn't work, right? This bit me in the butt a lot when I was first sort of like viewing my functions as data. I was expecting is vote string to return an integer, But what I really wanted is the return value of isVoteString to return to be negated. What this is doing is we've negated a function, which is totally meaningless, right? We have a pointer to a function and we've negated it. So to negate the return value of isVoteString, that's what compose does, right? It takes one function and runs the output of that to another function. So let's define a function that negates. And it turns out that our friend not does just that. So not takes in something and returns a boolean. Var not is a function that takes in x and returns not x. Right? That's all not does, what we define in the slides. So here we can say compose not is vote string. So we test to see if it's a vote string, and then we negate it, right? And then that's what we're trying to find. And then we run it, and we have our users. And then obviously for some strings it won't find it. So for this guy, it's this string right here, right? Our tuple is two numbers simultaneously back to back. It finds the first one, and then it finds nothing else. So we have bad data. So our next step in the process of sort of taming this is to filter out all this bad data. And as it turns out, that's the exact verb we want. So we want to use filter to remove all this bad data. And the call signature for filter, again, is similar to vote. It accepts a predicate, and it takes a list of items, right? And the predicate, in this case, is if this vote is valid, right? So is valid vote. And the call signature for this guy looks like this. It takes in an object, and again, we could say vote object, right? And it returns a boolean. So how would we actually check to see if this vote is valid or not? Vote. It's actually pretty simple. Enter, there we go. First we check to see if the vote exists, right? And then we check to see if the vote has points. And then we check to see if the vote has a username, right? And then if all those criteria are satisfied, then we're going to say, hey, this vote is valid. So we're going to use it very similarly to how we did it used map, right? So we're going to call filter with is vote valid. Now if we rerun this, we got rid of all our undefineds. And sort of this is the trend of functional programming. We have our small building blocks, they're all curried, and we build new functions out of the small functions. And now to address Ron's point, we have a ton of duplicates, right? We have Kevin in here at least 5 times, and I would love all the votes, but I don't deserve them. So we need to filter these, we need to make sure we have unique objects. Underscore already has a function called unique, and I believe what that does is it just looks for simple uniqueness. So it makes sure there's no duplicate strings, no duplicate integers, no duplicate booleans, but it sort of fails on objects from what I found. So we can very quickly make a unique by function, and what unique by will do is
There without?
Huh?
Isn't there without? Or is that?
without. There probably is.
I think there's a dot without, but I don't know what kind of it is.
I'll have to look into it. But I just wanted to demonstrate making new methods because that's so much fun. So unique by, what it does is we specify a property. So in this case, we'll specify username, and it goes through your objects, and then it makes sure only one of those types of properties exist. So if we say unique by username, it makes sure there's only one Kevin in the list, and then only one test, etc. If we say unique by points, it'll make sure there's only 1 + 1 and there's only 1 - 1. Okay? And we'll use sort of our existing methods to do this. So we'll make unique by, and then this will take two things, right? It'll take a string, which represents the property we want to work on. It'll take in the array, the data, right? Array. And then it will return a filtered array for us. So let's define this, unique by. And we'll actually have to use a function this time. And then notice how I'm using curry right here. The reason, again, why I have to use curry is we have a function with two properties, right? We have property, which is a string, and we have list, which is an array. If we wanted to add this to our compose chain and we had two properties, and what this chain is passing along is just an array, right? So it wouldn't work. So we are going to use curry to sort of help us along with that. And again, just like everything else, it can be made out of reduce. Man, reduce has been like my new favorite thing every day, all day. So we're going to call reduce with an empty array. We're going to build up from scratch, and then we're going to call it with our list items. And then we're going to pass it a new function. And we're actually giving all the properties to reduce because when the outer function is satisfied, we want the inner function to return immediately. Okay, so the first step is to get all the properties that already exist in the reduction. So items in memo, right? Oh, first we have to define these guys. Memo and then item. So items in memo equals, and then we're using our pluck, right? Pluck is the most, well, at least what I feel is the most common use for map. So pluck username from memo. So what this is doing is it's going through our list of users, or our votes, and returning username. So at this point we have a list of strings, and those strings represent usernames. Right? So our next step is to see if this user that we're currently on already exists in the reduction. So item, or yes, is in memo, right? We can use index of or find or anything, right? But we'll use index of. So index of just sees if this item already exists in the list. If it does, it returns the index, or it returns -1, right? So we're checking is items in memo, and then we're checking to see the item property. So in this case, we're checking to see the username of the item. Does the username of the item already exist in the usernames of the memo? And then we return if is in memo, we return, if it's already in the memo, we just return the memo because we don't want to return duplicates. Otherwise, we push it onto the stack. So push item onto the memo. So this is a little bit confusing. That's okay. We can go over it later if you all want, but that's just sort of unique by. And then we can call it down here, unique by, and then username. Then if we run that, we see we have our filtered list. And then to sort of show how we can do it on other things, we can just call points. And now we have, well, I guess that didn't work. Ignore what I just did because, whatever, username. So,
Items in memo up there.
Yeah,
You're plucking prop, not plucking username.
where do you see that?
There.
Right there.
Ah,
Yeah, hard-coded.
hard-coded. How embarrassing. Prop. Let's try that again. This is points then. Points. Run that. There we go. Good catch. So username here. So that's sort of all of this in a nutshell. Now you might think to yourself, why would I ever want to do this? This is just confusing and it hurts your mind. Let's sort of go through what we actually did. First, we're going to, let's close this a little bit. Let's break up our application into parts, right? Let's make it a little bit smaller, not bigger, smaller. So we have our general API, and we have our application-specific API. So this really shines when we have large applications, right? Application. And when we have a large user pool. Not is a very general function. In fact, in a lot of functional libraries, not's already defined. I think in Prelude, like in Haskell, not's already there. A lot of stuff. Similarly with words.split. A reasonable functional library will have these separators for you already. Array2tuples is general It's not your most common use case, but we can stick that in a library, right? If you have these sort of methods that you go back to every day or project-wide, we can put this in a utils file and we don't need to worry about it anymore. And unique by, right? Unique by is actually pretty useful in your everyday library. You won't find it. It might be in Lodash, like you said, what's it called, without or something. It might already be in there. But it's just another example of a method that we don't need to worry about. So had we assumed that these methods already existed, what did we have to do to get this working? We defined 3 methods. And of those 3 methods, 2 of them were predicates. They just returned true and false. One was a regular expression, and one was just a string of ands, right? The only sort of complicated thing we had to do was find out if our tuple had a string and a vote. The next sort of sticking point is this behemoth down here, right? This thing is huge, but one of the beauties of compose is we can just break up the composition. So we could make another function called getVote, right? And this getVote takes in a string and returns an array. And all getVote is, var getVote, is just compose. Compose. And we just copy these functions. And we've made a function just by moving things around. We don't need to worry about state because our functions are pure. We don't need to worry about any of these things. We're just making functions on the fly when we need them. Similarly, we can say filter vote, right? Filter votes, and this guy accepts an array and returns an array, right? So var filter vote votes is again composition, and we're just calling unique by, and we're calling isValidVote. We move this guy up here. And then to get our application in a running state, we say filter vote, and we say get votes. Get vote. And our functions and our application still works. And you know, even though like you realize we can sort of move things around like this, still, why would you want to use compose, right? It's still a little bit convoluted if you're not used to it. But the benefits to composition are very subtle, right? Let's say array2tuples is asynchronous, right? Let's say it's actually an AJAX call to find out if this array is, or not array2tuples. Let's say isValidVote is an AJAX call. We don't possibly have enough CPU power to check to see if this vote is valid, so we ping it to a server. With the power of monads, right, we can just map over this. And we don't even need to worry about being asynchronous. It'll just work, right? So we just say fmap, right? And then we treat it just like a normal type. And then the composition will just work. What happens if this task is terribly expensive and we want to cache this? We can make a custom compose method called composeM. And what this does is memoize, right? So if we see the same data coming in, we can just read out the memoized data, and we've reduced all this complexity. And all of this is just by changing the implementations. When you're not worried about the details because they're defined somewhere else, you can override the details later to suit your suit cases in that moment, which are sort of cool. So that's sort of the end of the demo. I'm just sort of going to recap everything.
What was fmap?
It's a monad thing.
Is that a standard?
It's fmap standard, I guess, a standard name. I think it's called return in Haskell or something.
I don't know if it's in.
So fmap is just how you interact with monads. Some people call it return, or some people call it. It has a bunch of different.
I've never heard the word
monad. So a monad is just, maybe wrong to explain it better, but it's just a wrapper around a data that sort of abstracts away some stuff. So like, for example, jQuery. The jQuery object is a monad.
Oh, okay.
A promise.
Unfortunately, no one can be told what the monad. Another example of a monad is a promise, right? If you tweak promises just a little bit, then it's a monad. And that's why, so we can get sort of with some crazy stuff.
Perfect, yeah. Thank you.
So lessons learned. Keep your method short and to the point, right? If you're building a house out of Legos and your Legos are the size of like 10 feet tall or whatever, it's harder to build houses. So, you want your building blocks small, keep your functions small. That way you can compose over them. Stick your data as the last parameter. This is why I had to use score under, right? Because underscore puts its data as the first parameter. So when you're trying to curry, when you're currying right to left or left to right, the first thing you have to pass is your array, it just wouldn't work. I can show you an example, but it just doesn't work nicely. So if you make your functions in such a way that your general parameters are first and your data parameters are last, things become much easier to compose. Along those lines, optional parameters are hard in functional programming. It's better to for one thing, when you have optional parameters, your function bodies are complex, right? Because you have to deal with different use cases. So if you split out your optional parameters into two methods, your methods are simpler. You might have a little bit of code redundancy, but that's where currying comes in, right? You built in your optional parameters as required parameters, and then you curry them to have two methods. And then lastly, the most important part, the one thing that I would take away from functional programming from a JavaScript perspective is strive for purity, right? The more methods you have that are pure, the easier your code base is to reason, to test, to maintain, to do all of these things. Because you don't need to worry about state, you don't need to worry about contamination, you don't need to worry about side effects. So that was a long talk just to tell you purity is pretty cool. And then, hooray, Willow Tree. I guess I had to put that in. So questions?
So if you were at a point where you needed to choose object-oriented rather than functional, what would kind of be the criteria that tips you one way or the other?
So, well, my current state of mind is I've taken the worst of both worlds. So if you look at my code, it's horrid.
You just want to do it?
I really want to do it, but this is why I wanted to talk about it. I don't know enough about functional programming to do purely functional stuff. And at the same time, I see all this functional programming and it's so like shiny and new and I want to do it. So like I'm taking like the small things and I'm taking out all the good parts of object-oriented, which is, inheritance. And sort of I have this monster right now. But sort of how I would divide the lines between when to use functional and when to use object-oriented, I've heard it said that when you're modeling data, use object-oriented, and no, it's the other way around. When you're modeling data, use functional, and when you're simulating data, use object-oriented. So like or in other words, so like with Autobot, sort of this string stuff, you can think of the data as flowing, right? Because we're just sort of modeling the data. We're sort of just running tests on data. I don't know. I really don't know when to use functional programming. I'm just sort of like applying it to everything and it's not working.
So what's the difference between modeling and simulating? Simulating would be more like...
Maybe I used the wrong word. Is it modeling or computing? I don't know.
I have no idea where you're going with this, buddy, so...
This is all me. This is all me blabbering.
It's all on you.
It's all me.
Computing makes more sense. I think that generally, that's kind of what I was thinking as you were explaining things, was that it seemed like if you want to model your domain, it's still helpful to use object-oriented programming, but then once you get around to actually processing data, it'd be nice to use functional.
Can you explain why Kevin is -1?
Why? Because I
Given
made
the data. I mean, how am I supposed to read the data for the input?
Pardon? One more time.
How can I read that data for input in order to get Kevin equals to -1? I mean, I saw what you did, and thank you very much. It was a very nice discussion. But I'm just having a hard time going -1 Kevin plus 1 Kevin plus 1. What is that supposed to mean?
What does some real data look like essentially?
Well, that data, for instance,
That's
is somebody's doing -1s and +1s on somebody. You're grabbing someplace in that stream. You don't really know if you're starting with Kevin or -1.
So
and yet you interpreted that to be a Kevin as a -1. And
So the way sort of we've settled at Willow Tree how to interpret this is left associative. Mm-hmm. So if you're trying to put a vote on someone, you look for the vote on the left and then the username on the right. Mm-hmm. But you also accept the other way around, the username on the left and the vote on the right. So if both exist, we just drop the second one.
So why doesn't that string count as a vote against Kevin and a vote for Kevin and a vote for Test and a vote for Joe?
Because we only want one per, right?
Okay, so you just make the policy that you can't vote for someone twice
Twice.
in the same line.
Yes.
Okay, thank you. Thank you.
Hello?
So that was a whole ton. What else?
Okay.
Or we can just sort of like, does anyone have anything else they want to talk about or anything else cool? I just sort of dominated the floor for a long time.
Well, so something I didn't do because I don't run the meetup, but typically you guys like to go around the table, go around the room, everyone introduce themselves. So now that you've gotten everyone warmed up, Kevin, I think it might be a good time for people to say hi. I'm so and so.
Sure.
Does that sound like a fair proposal?
Yeah, absolutely.
All right, Gilman, go ahead.
I can start, Gilman Carlson. I work in area from home, which is awesome on,
Can you your company area from home?
what's that? No, yeah, my company name is From Home. Right now I'm working on an analytics company and I'm loving Angular and I'm working with the JavaScript Meetup group, trying to help organize all these meetups. So thanks for everybody for coming and thank you very much for the talk. Yeah, so I love Angular and JavaScript generally, and now functional.
Owen Zanzo, I currently work for Click to Mail, but that's about to change because I just got a offer from Vivid Cortex. So
Nice.
looks like I'll be going there.
Nice.
I'm Ben. I work for Boyd, Keaton, and Grant. They're kind of all over the country, so I also get to work from home. And I make games in my spare time, and that's why I do more of the JavaScript, actually. We do a lot of PHP work.
My name's Matt. I work for Lear. I've only been there for a week and a half, supporting a very large, very convoluted, very boring app. So I'm very glad that I can come and do things like this. Fantastic demonstration, by the way.
My name's Dan. I work with Ron and Kai here at Private Practice. I don't really have anything more to say.
I'm Roland. I work for Booz Allen Hamilton that does defense and other types of contracting. I'm a Java developer mainly, but last few months I've been learning JavaScript and using Dojo, so I'm going to look you guys up and learn some things.
I'm Kevin. I work remotely. I work for a company in Alexandria, and I do mostly front end work. So.
I'm Adam. I work for Willotree Apps. I'm in the DevOps team, so I've seen a lot of Ron's code. I do mostly Python, but every now and then I get to work on the web apps or with the web apps guys and do Java or JavaScript. Sorry.
I'm Kai.
I work with Dan and Ron here at Private Practice and do, I guess, most of the front end on our newer products, as well as some server-side stuff too, JavaScript and Python.
I'm Andy. I am a second year at UVA, and I also work at Roomkey. Work on the front end team.
I'm John, and I also work at Roomkey. I've had the good fortune of working with at least 3 guys in this room, all of whom I've learned a lot from, so it was an excellent presentation. And I pretty much do front-end stuff just like Andy, so CSS and JavaScript.
I'm Ron. I introduced myself at the start. I'm glad you guys are here. I'm glad there are a lot of people I haven't met yet. And I also think it's really interesting that Willowtree's at a point where I have no idea who's working on my code anymore.
My name's John. I'm in private practice. I don't work for them. Past couple of years I've worked in .NET, ActionScript, JavaScript, Ruby, Rails, and now I'm playing with Clojure. And hopefully the Clojure and the functional JavaScript will lock at some point and make more sense. It makes plenty of sense, but it's still not the way I think. I don't think constructively from those pieces.
The book Functional JavaScript by Michael Fogus, he's one of the core contributors to Clojure. So a lot of the JavaScript he writes is Clojure style.
Mm-hmm.
So
I'm looking forward to seeing more of that. This is great. And that video that goes with this that you put on the thing if we had time, I'd say just put it on in the background because they work well together. It's 38 minutes, I think. And it's very succinct and covers much of this territory, but from the angle of more or less underscore bashing.
Yeah.
Can you 100% on Meteor.js in the future?
What am I presenting?
Meteor.js.
Oh, that'd be fun. Yeah, I spent a whopping weekend with that.
Oh.
Feel like I'm deeply into it. It is a brilliant and interesting method, but it's a little bit closed. So, everything's going back to client server, and I like the separation that you can get with a more functional back end and a front end. And it'd be nice if they all use the same language. So, hopefully we'll get there. But I'm doubtful.
Well, I'm John, and I wish I had seen your presentation, but I was at a meeting learning about starting a business, so can't do both. Anyway, thank you. I hope I can get some notes.
There's a chair if you want.
Oh yes, but I didn't want to disturb it.
You've managed to do both a couple times.
Kevin has all this stuff on, John, all this is on the Meetup site. He's got links for everything,
Well, great.
including this bin and his slides and everything.